Free audio post-production by alphonic.com.
Yes, but this was the flip to me.
It is now 6 o'clock, so
It's now
let's get started. Oops. So, welcome to Specific Gravity into the black hole of Brewing MEAD. I'm Dave Aronson, a Mensa and a Mazer. Can everybody hear me just fine out there in the back? Okay. Now, a Mazer with an S in the middle is a microwave laser, obviously that's how I am. With a Z in the middle, it's a certain type of bowl cup often used for drinking mead, and nowadays also means the person who makes mead. And for many of us of a clickers
Did you turn it on? Sometimes you have to switch them.
Yes, this one is turned on. See, the laser. But anyway, I'm right here at the end. We have a question in the back.
What's me?
I'll answer that. Good question for those who didn't hear what's me. Anyway, since I'm right here, I can just click the button rather than the clicker. Oh, well. Anyway, for those of us of a rather scientific mindset, learning the concept of specific gravity tends to be the marker of the event horizon where we really get sucked into making mead because we find out, it's mostly based on this relatively simple math. Now, more complex than most ordinary people want to do, but, this not calculus, not even differential equations. So maybe some middle school level algebra is about it. But still, most people don't want to do that. So that makes it right up our alley for us geeks. Now, before we get started into the subject, what it actually is and how you use it, I want to answer the big question on everybody's mind, other than what is mead in the first place. Sorry, no, I'm not giving out samples. At least that they'll talk. I did bring 4 bottles, so who knows what you might catch me with as I wander around and go see the presentations. Speaking of presentations, some of you may have seen my talk a few years ago. I think we have another question in the back. Oh. No? Okay.
Well, are you talking about actual black hole?
No. It's a metaphor.
It's an alcoholic product, mead.
So it may cause you to black out if you drank enough of it or rather too much of it. But no, the two topics are not actually related. Anyway, where was it? Some of you may have seen my talk here a few years ago on the basic history and making what is it of mead, but I'm guessing that a lot of you did not. So we'll start with a brief recap of the major points. First off, to answer the young gentleman's question, what is mead? It is an alcoholic beverage similar to wine, but made by fermenting honey rather than fermenting fruit. That's the primary difference. It's generally thought to be the world's oldest alcoholic beverage, and the oldest evidence we have of its production dates back to about 7,000 BCE, in other words, about 9,000 years ago. And despite how most people associate it with Vikings, this evidence actually comes from China. In every place where there were honeybees productive enough that humans could harvest enough honey to make mead, it's found its way to the culture, including not only all over Europe and Asia and even Africa, but also parts of South and Central America. It can be made lots and lots of different ways, not only in the process, but also in the end results, including things like the sweetness, the strength, whether it's carbonated or not, whether it's flavored or not, and with what. It can be served chilled, room temperature, warmed, even hot, or alone, or in a cocktail, any way you want it. Making it can be quite simple. At its simplest, you just mix up a little honey and some water. Ideally, cover it so bugs don't get in, but don't seal it up tight so the carbon dioxide can't escape. That's something dangerous we'll touch on a little later. Then let it sit for a while, probably about 3 weeks or so, somewhere around room temperature out of direct sunlight. And then, ta-da, you've got me. But with a little layer of sludge on the bottom, composed mostly of dead yeast, some live yeast, and a few other things from the honey, like some pollen and some proteins and other things. Most of the rest of my previous talk was about how different cultures made it and drank it in different ways and so on, and how to make a small batch very simply at home with things you're practically guaranteed to find at your typical local grocery store, and what we actual hobbyists would do differently from that. So this talk is mainly about one of the two most important things about actually brewing mead. To touch briefly on the other one, which is actually to some extent more important, that is to sanitize your equipment. But there's not really all that much one can say about that. Mainly, to quote Nike, just do it. But what do I mean by sanitizing? What's the difference between just clean and sanitized? In the brewing world, clean doesn't mean quite what you think it is. There are basically 4 levels of cleanliness we usually refer to. Dirty means there's visible grime on something. Clean just means there isn't. That means nothing regarding microbes. So we want things sanitized.
I haven't seen that though.
And sanitized means basically as free of microbes as reasonably practical without major expense and effort. Those of you who did see my talk here 3 years ago might recall me saying very clean. That's basically a layman's terms for sanitized. And the last level is sterilized. And we mentioned that mainly in the context of what we don't really need to achieve. This isn't open heart surgery. We don't need to autoclave everything. In fact, even sanitizing isn't strictly necessary, but if you don't do it, you're probably going to wind up with some batches having various infections, ruining it, and you're just going to waste your time and life. So, how do we sanitize our equipment? There are sanitizing solutions mostly sold as concentrates, so we mix up some reasonable quantity, like a half gallon, or if you're doing a big batch and so you have more equipment, maybe a gallon or 3, whatever. And make sure that every surface that's going to touch on mead is wiped or sprayed or soaked or whatever with the sanitizer. This one, Star San, is a very reasonably priced, colorless, odorless, tasteless, non-toxic, no rinse foaming cleanser. So it's very popular.
Yes.
No rinse. Yes, you don't have to rinse it off.
Why?
Because it's colorless, odorless, tasteless, and
Why would you not want it?
Why would you not want it? Well, you're right. If your water is very, very clean, you could do that. But the sanitizing solution is probably a lot cleaner than your water.
What are the basic chemistry of that?
I don't know the exact type, but it's acid.
It's got
Phosphoric acid.
And there's another acid
Oh,
in it.
real good. In case you didn't say it's phosphoric acid. Yeah.
So interesting plating on things. So
So,
see, if you can use like dish soap and rinse.
oh, yes, if you use dish soap, or for that matter, bleach. Some people do that instead if you can't get a hold of this for whatever reason. And yes, then you have to rinse very well. With Star saying, you don't bother. Now, moving on to the main topic. The most basic aspects of a batch of mead are the sweetness and the strength. And these are a balance. Given a set amount of honey, we can make it stronger, but that's going to make it drier. Or we can make it sweeter, but that's going to make it weaker, unless, of course, we add more honey. So how do we plan out what a batch of mead will be like and measure the strength and the sweetness? This all boils down to the concept of specific gravity. Hence finally the connection to the actual topic of the theme of the RG. Now, I don't mean as opposed to general gravity. You might remember from your high school physics class that the specific gravity of a substance is its density divided by that of water. So something twice as dense as water has a specific gravity, often abbreviated to SG, of 2, and something half as dense as water will have an SG of 1/2, and so forth. The specific gravity of honey varies pretty widely, due mostly to moisture content, but it's usually in the neighborhood of 1.425. So for the purposes of general planning, we usually stick with that. In particular batch of honey you get, especially from farmers market and so forth, may be very different from that. But for planning, we'll just stick with that. It's very convenient. It works out to just a hair under 12 pounds per gallon. So we often use that as a shortcut. And we'll be doing a little bit of math later on. You'll see that shortcut used. Even without that shortcut, though, it works out to about 1.5 ounces avoirdupois, in other words, standard weight ounces per fluid ounce. Don't get me started on our silly American units. So, the SG of alcohol. Yeah, I was going to say something that I decided to chop that. The SG of alcohol, particularly ethanol, the kind of alcohol we can safely drink with amazing, is 0.789. So if we mix up some honey and some water, it's going to be water plus something denser than water, so it winds up denser than water. And as the sugars get converted to alcohol, well, sugars and some water get converted to alcohol and some carbon dioxide that escapes, the specific gravity decreases from the start where we measure the original gravity down to the end where we measure the final gravity, which we often abbreviate to OG, not to be confused with original gangster, and FG, of course. And we can make use of this fact to tell its villain, because as you can pretty well see, the SG will be stable. We usually consider it done when the SG reading is the same, about 3 days apart. And you may be wondering, okay, so how do we read the SG? This is not a high-tech Harry Potter one. Specificus gravitatum. This is a hydrometer. It's a very simple device. Things like this date back to ancient Greece, in fact. And you just plop it in some liquid, and assuming the vessel is tall enough, it will float to a place that indicates the specific gravity on this scale here. So that's how we do that. Okay. Now, the SG also corresponds somewhat roughly to how sweet it is. Since the vast majority of what will affect the specific gravity, other than water and alcohol, is sugar, especially when we're dealing with just plain honey. There are some other things in there, like some proteins and maybe some pollen, depending how well filtered it's been, maybe some dead bee parts and so on. But they're a very small proportion compared to the sugar. So we usually just assume that everything above 1 in its specific gravity is due to sugar. We don't tend to be terribly precise about all this, unless we're selling it, in which case the taxman wants us to be very precise, or entering competitions. Then they may or may not want us to be very precise. Anyway, there are other things that affect the perceived sweetness, such as the tannins and acids and alcohol and the temperature. But ignoring all that, there isn't any standard but I go by roughly this chart. You don't really need to memorize that. Just know that. Forgot I put that in it. So, anyway, all that is about the finished product. So how do we plan it out to wind up there? First, we have to figure out how much sugar is going to get converted to alcohol. And then we have to figure out how much honey we need to supply that much sugar. The math for that is easier if we stop thinking in absolute numbers and think about the change in specific gravity and assign it a unit that we call gravity points. These are usually abbreviated to GP, and they're 1,000th of 1 unit of specific gravity. So you can think of them as sort of a milli-SG. If it helps you remember it, you can think of specific gravity as being so valuable in your quest for mead that it's worth 1,000 gold pieces. Now we can figure out the percent alcohol by volume, ABV, from the drop in the specific gravity over the course of the fermentation, or as we say, the delta SG, the original gravity minus the final gravity. And to figure this out, we divide that drop by 7.62 GP per percent ABV. And that's one of the reasons we actually assign it a unit of GPs, so we can do a unit check on our math. Make sure we got the formula at least close to right. And we can plan our delta SG, let's figure out how much drop we need by flipping that formula around and multiplying our desired ABV by 7.62. So for instance, if we want 12%, typical wine strength, then we need 12 times 7.62 or 91.44, which would just about to 91. Okay, so I'm not usually very precise. 91 GPs worth of sugar, in addition to any sugar we want left over or added later to provide its sweetness. Right now, we're just talking about the sugar that gets converted to alcohol. So supposedly when it's somewhere around the middle of the semi-sweet range, let's say 1.017, then we need the 91 GPs for the alcohol plus another 17 to get it from 0 up to get it from 1.00 up to 1.017. That totals up to 108 GPs, meaning that our original mixture of honey and water, what we call must, should be at a specific gravity of about 1.108. As remember, this is the added sugars. So how much honey do we need to use in order to get to an SG of 1.108? As I said before, honey weighs about 12 pounds per gallon. It's actually about 11.892. And if we take the 425 GPs worth of sugar and divide that, then we get 35.7 GPs per pound, which means that each pound of honey contained in each gallon of our must contributes 35.7 gravity points. And to make the math easy, we often just round that to 36. You may see some people say 35. They're dividing by 12, not 11.892. So, depending exactly what they're doing, it may make the math a little easier for them, but 36 is closer to correct. And for some of us, the difference between doing math in our head with 35 versus 36, it's not a big deal. So I use 36. So for instance, if we use 3 pounds per gallon, and that could be 3 pounds of 1 gallon, 6 pounds of 2 gallons, whatever, then the specific gravity of our must will be somewhere around 1.108. Actually, it works out to closer to 1.107, but like I said, we're usually not terribly precise in the rough planning stages. And yes, that's why I chose that particular desired sweetness. So it would work out to exactly that. And this ratio is about typical and rather convenient. Like I said, 3 pounds, honey weighs about 12 pounds per gallon. So 3 pounds is one nice even quart. And that makes for a very easy to remember volume ratio of 3 parts water to 1 part honey. And we can scale this up and down to different sizes. We'll make it 10-gallon batch. Fine, just multiply it. Or if you want it weaker or drier, sweeter, stronger, you can tilt it one way or the other a little bit. We typically use somewhere between 2 and 4 pounds per gallon. Thus, if we're adding something else sweet, we'll see an example of that later. Before we move on from this particular calculation, one very important factor is that I'm speaking of each pound of honey contained in each gallon of must, not pounds per gallon of water that goes into the must. This is a very common mistake among new mead brewers. So, for instance, if we added 3 pounds of honey to a full gallon of water, we'd have a total volume of 5 quarts, not 4. So it would be less dense. The gravity contribution of the honey would be only about 4/5 out of what we want. There's one more very important factor that I haven't mentioned yet in this talk, but I did mention in the previous one, and that is that different strains of yeast have different alcohol tolerances. That's the level of alcohol, usually in percent ABV, at which they'll allegedly go dormant and stop processing any more sugar into alcohol. So the ABV formula is really more like this. The smaller of either the yeast's tolerance or the alcohol we could produce with the given amount of sugars. Now, in our particular example, we said we wanted 12%, so we should choose a yeast that stops around there. The problem is that this isn't very exact. For most yeast, their official listed tolerance is more what you'd call a guideline than an actual rule. It means they'll probably stop somewhere around there, usually between 1% ABV less and 2% more, with more being more likely than less because the manufacturers don't want you to feel screwed over by an underperforming yeast. So in this case, we probably would actually choose a yeast with an official listed tolerance of 10%, because most of us use a guideline, I should say a guideline, of about 2% over the tolerance. And that's not hard to get if you treat it well. If the yeast poops out at a lower ABV, our mead will be weaker but sweeter, and because less sugar will have been converted to alcohol. And if the yeast keeps on trucking, it'll be stronger but drier, assuming there was any sugar left to convert. Anyway, because of this inexactness, this method of adding all the alcohol up front for both adding all honey up front for both the alcohol and the sweetness, and hoping the yeast stops at the right place, is often called pitch and pray. Sounds like a lot of you already know that the act of putting the yeast into the must is called pitching the yeast, hence the term. So what should we do instead? The alternative involves something I left out of the first talk, which is stabilization. And there are 2 main ways to do that. The first is heat, in other words, pasteurization. But that's rather difficult to do correctly with equipment that most of us can afford and fit into our homes. So I'm not going to go into that. And that leaves us with chemicals. There are 2 main chemicals we use for this. And the first is potassium metabisulfite, often abbreviated to K-meta, because of course, K is the chemical symbol for potassium. This audience probably knows that. This one is an oxygen scavenger. Yeast need oxygen in order to breed. So an oxygen scavenger prevents that from happening. The other chemical is potassium sorbate, often abbreviated to K-sorbate or just K-sorb. And I don't know how that one does it, but it prevents the yeast from eating. Now, if we had only used the K-meta, then the existing yeast could eat. And if we only used the K-sorb, then the existing yeast could breed and their children could eat. So we really need both. You may also hear of Campden tablets. That's basically the potassium metabisulfite in pill form that you crush it up or maybe just let it dissolve. And I usually just measure out some powder. However, these chemicals are not really all that strong, so they shouldn't be used to stop a fermentation that's still in progress. They're best used to just ensure the finality of one that's already run its course and become stable. And we do that because we may want to add some more sugar. That very few people really like the down around SG 1.000 and possibly even below. That's just way too dry for most people, including me. Now, not stabilizing introduces the risk of the fermentation starting up again later. And you might think, hey, Ray, more alcohol. Hey. But it might mess up our intended outcome. That'll make our mead stronger and drier than we probably wanted it to be. Worse yet, if it happens after we've already sealed it up tight, such as by bottling it, and CO2 generates a lot of pressure, we may have on our hands, oh yeah, I see, you know what's coming. You might have a bottle bomb. And that may sound like fun, kind of like a bottle rocket. But no, it's not only messy, getting mead and broken glass all over the place, but it can hard enough to injure you if you get hit by the flying glass shrapnel. Do we have a question?
Can you control it to the point where you will have sparkling mead?
That's exactly the next sentence. On the other clause, both carefully, right? This is how we get naturally carbonated mead, as opposed to having to force carbonate it with a CO2 tank or a nitrous stick or whatever. However, that's a little tricky to get right. Most people who do this have had some bottle bombs in the past. So I honestly have not even tried it yet. So maybe after I have done it a few times and maybe even done it right, maybe I'll do another talk on me and include that there. So what we do instead is first we mix up our initial must with just the honey we want for the alcohol. Then we pitch a yeast strong enough to eat up all that honey. And let that run totally dry. By which I mean let it eat up all those sugars. Don't stop it until it's done. And stabilize with those chemicals. Then add the honey or maybe other things that we want for any sweetness. And this process of sweetening it back up, or you could think of it as sweetening on the back end rather than the front end, is called back sweetening. And I'll be using that term later on. Now, this may sound a little more complicated, but in reality, it's a lot more complicated. Mainly, we're adding things that take up some volume after the fermentation. So not only will that change the sweetness as we intend, but it will also lower the alcohol by volume because we're increasing volume. So if we want to really plan it out right, we have to work backwards from our final intended strength and sweetness and volume, figure out what we need to add to it from the result of the fermentation, and then figure out what that result of fermentation should be. Well, kind of got that backwards. Figure out the result of the fermentation is going to be, figure out what we need to add to it, and then figure out how to get to that fermentation result. So if we were going to add another 6 ounces of honey by weight, remember that rule of 1.5, that means it occupies 4 ounces of volume. So if we add that to 1 gallon of freshly fermented mead, we have a net volume of 132 ounces, right? There's another complication. When we stabilize it, we lose some because we do this by transferring it, usually with a siphon, from one fermentation vessel, or as we sometimes say, carboy, from one to another. We don't just put the chemicals right into the first one where it did the fermentation, because we've got that layer of sludge on the bottom, which includes some live yeast. And we want to minimize that for the sake of the effectiveness of those not all that strong chemicals. Also, we just want to get it away from all that sludge just for taste purposes and clarity and other such reasons. And we lose some mead because some of it is part of that layer of sludge. It's not a dry cake of powder. It's wet. And additionally, some because it's so close to that layer of sludge and we can't easily siphon it out without also getting some of that sludge. And since the process of siphoning it from one carboy to another is called racking, this is often called racking losses. Some people also call this the Valkyrie's share, analogous to the angel's share taking out of whiskey as it ages in wooden casks, though through a completely different process. Back sweetening, oh, yes, it's hard to predict how much exactly we'll lose, but I usually do 1 gallon batches, and I usually estimate I'll lose about a cup. Back sweetening also involves one more thing that we can't quite predict very accurately, and that's the final gravity, or FG. It will almost certainly be in the general vicinity of 1.000, but it could be anything from about 1.002 down to 0.992. I usually plan on about 0.998, which is about typical. I've seen it as low as 0.994 myself. So that little spread, it doesn't make too much of a difference. Just have to then be aware of it and adjust your plan accordingly. Just like with the racking losses. If you have a little more losses, yeah, you're going to have to add a little more water. Less losses, okay, don't add quite so much. So now that we have some reasonable guesstimates for our final gravity and our racking losses, we can get back to actually planning out a batch. Assuming we're still using just honey and water, we now need to figure out how much honey it would take to contribute 19, not just 17, GPs to a gallon of mead to get from 0.998 up to our desired gravity of 1.017. Well, fortunately, we're trying to get back to a nice even gallon, so we can use some of our shortcuts, and that isn't quite so hard. Dividing the 19 GPs by 36 GPs per pound gives us 0.527 pounds, which is 8.4 ounces avoirdupois, which occupies 5.5 fluid ounces. So that's enough math that most people really shy away, but we're medicines, we can handle it. So That means that the last step in this entire process is going to be to add 5.5 fluid ounces of honey plus, what would that be? Yes, 2.5 fluid ounces of water. So that between them, we get enough sugar to get it back up to where we want, and we get enough total volume to bring it back up to a full gallon. Y'all still with me? Seeing a lot of nods out there. So, what are we going to add that to? Question.
So do you do this immediately after you've racked it? Or do you wait until it settles some more after?
Okay, do you do this right after racking or let it settle? I usually actually rack it twice to get more yeast away from it. But I'm simplifying something. I estimate that I'll lose about a cup, but that's usually 4 ounces at a time. Your mileage may vary, especially when you're just starting out. You might get losses of a full cup each time. Once you get really, really good at it, you might even be able to cut it down to like a quarter cup each time.
So you rack it, and then there's some time for it to settle. And you rack it again, then there's some time for it to settle again.
Yes.
And then you add.
There's usually one thing I'm skipping here is the stage often referred to as cold crashing. And between racking and bottling, there's usually the way I've been doing it lately, at least 2 stages of cold crashing, 2 meats apiece. And that does is let the yeast settle out. You don't have to put it in the fridge, but that really helps. So your crashing doesn't have to be cold, but you often do that if we can. Any further questions before you go on? Yes.
So, could you ferment steak honey without adding any water? And would you get a proper, or is that just too sweet for the yeast?
Could you ferment just straight honey? No, you can't. You do have to dilute it, but some honey that you get from, well, I don't know what kind of source, but certainly any beehive that might have broken open and gotten raked in, it doesn't take all that much dilution to bring it down to where we naturally may be able to ferment it. So you do have to dilute it. We usually try to keep the SG under about 1.120 is usually considered a little high. I've done that. It's not too hard. If it gets like 1.50, then the yeast are really struggling and throwing off bad flavors. Higher than that, they can still do it, but you might not want to drink the results without a lot of aging. And that's, of course, another step I'm skipping in this whole thing. On general principle, the more alcohol there is in it, the longer it'll take to age to the point where it's pretty nice to drink. Not all mead really needs to be aged, but all of it can benefit from some. I do have some bottles I bought. Some of them are, one of them I bottled this morning. Another one was like last month, month before that. If you have the patience to let the mead wait and not drink it, you'll find it improves. Anyway, any other questions?
So cold crashing relative to racking, is rack then cold crash or rack cold crash, rack cold crash?
What I usually do is my initial fermentation, I let it sit long enough that a lot of the yeast has actually settled down. So I then rack from, I usually do mine in a bucket and then rack that to a jug style carboy and cold crash that because that fits in the fridge a lot easier. And then After 2 weeks, rack it again. Usually it does leave behind a decent amount of sludge that was still suspended in there. And then another period of cold crashing, then I bottle it. That seems to be enough.
Okay, where does I?
Oh, yes. Okay. So what are we going to add this 5.5 fluid ounces of honey into 2.5 of water to? Since honey and water don't contain alcohol, and you know how much volume we're adding, and what percent ABV you want to wind up with, we can figure out what we have to start with. In other words, what that fermentation product needs to be. So we're adding a cup of non-alcohol to 15 cups of mead, 1 gallon minus our estimated cup of racking losses. So the ABV will then be 15/16 of what we fermented to, so we should ferment to 16/15 of what we want. You said originally we wanted 12%, so 16/15 of that is 12.8%. So now we have to figure out how to create a batch that will ferment to 12.8%. The first step is to figure out how much honey will get us that in a given volume. It's still assuming 1 gallon. And to do that, first we have to figure out our desired original gravity. And as you may recall, how we do that is multiply our desired ABV, 12.8, by 7.62, and that gets us 97.5 GP. So that means that our original gravity should be around 1.097.5. So how much honey do we need to use in order to get that original gravity? We divide that delta, the 97.5, by 12 pounds per gallon, or 11.892 if we're feeling precise. And sorry, I skipped ahead of that. No, we divide that by 36 GPs per pound and get 2.71 pounds. So, how much water do we need to go with that? We could figure that out by dividing the 2.71 by 12 pounds per gallon and subtracting the result from a gallon. But there's an easier way. After you've added the honey and maybe a little water to start it diluting, fill it up to the 1 gallon mark. Now, a lot of carboys don't have a 1 gallon mark. In fact, mine usually don't.
At first.
First, yes, exactly. It's going to advise. If yours don't, when you get it, add 1 measured gallon and just mark what that came up to. So to recap the recipe, 2.71, actually we'll probably use 2.75. It's a lot more convenient, and like I said, they're much more about convenience than precision. Pounds worth of honey, water to a gallon, ferment with the yeast that's pretty well guaranteed to give you enough to give you the level of alcohol you want. Stabilize and back sweeten 5.5 ounces of honey, and then 2.5 of water to make up for the racking losses. If you have really good racking technique, you might not need to add any water. If you had fairly poor racking technique and you had bigger losses, we need to add more water, adjust as needed. So sometimes you need to add water to the speaker.
Is that 2.5?
I think this is about 1.000. No, that's cheating. But what if we're not just using honey and water? How does that change things? Well, if we're using herbs or spices, well, that's really easy. Just wash them pretty well, ideally sanitize them, plop them in after the fermentation and racking are done. Taste it once in a while, and when it's how you like it, take them out. No problem. But fruits are much more difficult. They contribute some sugar we need to account for. And if we're not using dried fruit, there's also some liquid volume. And we can also flavor mead with lots of other things, some of which contribute some sugar or volume of liquid or both or neither, maybe even some alcohol, like if we're using an extract or tincture. To work through an example, suppose we want to make a piment. And those of you who saw my previous talk or you otherwise know about mead, that is a mead made also with grapes or grape juice, which we often do for convenience and a little bit of precision. Very hard to estimate exactly how much sugar you're going to get out of a piece of fruit. So this leads to a definition question. If we ferment grape juice with 1 drop of honey, what do we get? I think I heard somebody say wine. Yes, that's exactly right. So at what point does it start being mead instead of wine? Some legal jurisdictions and competitions may have more strict rules or slightly different rules. Some jurisdictions say it has to be 51% of the fermentable, never mind fermented sugars being from honey. But for most of us, we just call it mead if most of the alcohol, maybe just enough, came from fermenting honey. So if we, on the other end of our reductio ad absurdum, if we mix up our typical must, 2.5 pounds of honey in a gallon total volume, and add 1 drop of grape juice, does that make it a pint? I haven't defined what that is, but you've probably guessed no. So what makes it a pint? The rules for that are basically the grapes are, or the grape juice is, present from the beginning of fermentation, and it's the dominant flavor after fermentation. So it has to be within a certain range. It has to be enough grape in there that it's the dominant flavor after fermentation, but not enough that it's the dominant source of sugars. Otherwise, it's wine instead of mead. So now let's start planning a batch of piment, sticking with our previous goal of 12% and SG 1.017, in the middle of the semi-sweet range. Working backwards like before, we know we need to add something that'll contribute 19 gravity points in the volume of 1 cup to get our SG from our likely final gravity up to our desired gravity and make up for estimated racking losses. So can we do that with grape juice? That depends on its specific gravity, of course. And it's reasonably simple to check if that's even possible. Now, the SGs of fruit juices vary quite a lot, even more than honey, but grape juice, the kind you get from the supermarket, not the kind meant for making wine, which is a little denser, is typically about 1.060. So if we take a sugar in 1 cup of grape juice and distribute that over a gallon of total wine, we see that its gravity contribution is only going to be 3 3/4 GPs, far short of the 19 we need. So no, we can't do that with just grape juice. But what about grape juice concentrate? Now we're at the obvious question now is, so what's the specific gravity of that? Again, it varies widely, but typically around 1.340, between that of water and that of honey. So let's see what happens if we add 1 6-ounce can and 2 ounces of water. Looking at just the gravity contribution of the concentrate, it gives us 16 GPs per gallon per can. That's much better, but still not quite there. If we use 8 ounces of grape juice concentrate, it fills the bill, but as far as I know, Grape juice doesn't come in 8-ounce cans, and it's kind of inconvenient to deal with leftover 4 ounces. And we could decide that 16 GPs is good enough, or we could decide that, yeah, we'll just mix up some grape juice with the other concentrate, or we could decide make 3 gallons and use 2 12-ounce cans, whatever. Or we could decide to use honey for at least some of those remaining 2 ounces. If we run the numbers with both ounces being honey, it overshoots a little, but if we dial it back to 1 ounce of honey and 1 ounce of water, we get exactly what we want. So now that we know what we need to back sweeten with, let's tackle the initial makeup. Using the same calculations as before, we know we want something well fermented 12.8% ABV, which will require an initial gravity of about 1.097 and a half. So how do we get there with some combination of water, honey, and grape juice or grape juice concentrate that will have most of the sugars in the honey, but still have a very strong grape flavor? Now, what I usually do for this kind of situation is take the total amount of sugar we need, cut that in half, bump that up to some amount that would be convenient to do with the honey, and check what that actually gets us, and figure out how to get the rest from the other stuff, in this case, the grape juice or concentrate. So sticking with our calculations from last time, we need 97.5 GPs worth of sugar in total. So we cut that in half and get 48.75. Divide that by 36 GPs per pound to see we need 1.35 pounds of honey, which is 21.7 ounces of weight, which occupies 14.4 ounces of volume. As Tom Liver, rest in peace, would say, Bonjour boy. But we're going to round that up to a nice even 16, 2 cups, 1 pint. Now we check how much sugar that amount of honey actually gets us. 16 fluid ounces of honey weighs 24 ounces, which is 1.5 pounds, so it contributes 54 GPs. One of the simpler calculations we've done here. So now we know what we need to get from the grapes, grape juice, grape concentrate, whatever. We need the remaining 43.5 GPs in a volume of the remaining 112 ounces. If we try to do that with grape juice and maybe some water, we're basically solving this equation in fluid ounces. The sugar in some number of ounces of juice distributed over 128 ounces contributes the GPs we want. And I'll spare you the simplification steps, but it works out to be 92.8 ounces, which of course we're going to round up to a nice even 96. In other words, 3 quarts. Very simple. Just to be sure, now we check our work, working in pints this time to make the math a bit easier. It's basically just a weighted average. So if we mix up 6 pints grape juice, 1 pint water, 1 pint honey, totals 8 pints, in other words, 1 gallon, and gives us a net SG of 1.098, spot on, at least to as many decimal places as we're using. To recap that recipe, you mix 3 quarts grape juice, 2 cups honey, 2 cups water, ferment with a yeast of at least 13% tolerance. Stabilize and back sweeten with 1 6-ounce can of grape juice concentrate, 1 ounce each of honey and water. So now you may be wondering, okay, what if I want a mead with a decently strong grape flavor, but I don't care if it could be technically called pine? Can't we just brew up some plain mead like we did the first time and then back sweeten with grape juice or concentrate or whatever like we did the second time? And yes, you're exactly right. And I've got a batch like that in progress at home. And to get that recipe, we just take the initial steps from the first recipe and tack on the later steps in the second recipe. Very simple. It won't have quite as strong a grape flavor as a pint because it only has the grapeness, for lack of a better term, that we put in the back sweetening, nothing in the original fermentation, but it should still be quite noticeable. Most of these calculations may seem like a royal pain in the proverbial posterior, and if you combine that with how the concepts are pretty well known, you might be wondering, hasn't anybody made an app for this? Or
Just an Excel spreadsheet.
Yeah,
That's all you need.
that's
actually, in Excel, Google Sheets is exactly what I started out with. But it turns out, yes, there are apps and websites. Surprise! The mobile app that I've usually heard recommended is called Brewfather, but it's aimed mostly at making beer. So there are a lot of things in it that you're not going to find useful for making mead and kind of get in the way. And there's some things that would be useful for making mead that aren't going to be in there. Oh well, it's still a lot better than trying to mess with a Google Sheets or Excel or whatever on your phone.
I didn't say Lotus 1, 2, 3.
Yeah, I remember Lotus.
I love that bit.
It actually wasn't bad for its time.
So much better than what was before.
Yes, not better than pencil and paper. Yes. I'm liking the thing that was before that. Anyway, yes, physical. Thank you. Anyway, as for websites, there are several that are frequently recommended. There's a site, gotmead.com, that has a very, very useful calculator, and another one called Mead Tools. But they're a little overwhelming and confusing, especially for new brewers. So I put up some simplified ones on my own website at Some of a Batch. Thank you. There's also some advice there on fixing batches that have gone bad in various ways, and some other blog posts, and eventually maybe some videos focused mostly on, as I did in my first talk, how to make a simple batch, a small batch very simply at home with just stuff from your grocery store. And that's all the time we have for these topics. If you have any more questions, we've got about brewing and its left. And if you think of something later, I'll be around for the rest of the RG with maybe some mead and little sampling cups. If you think of something even more later on, there's my email address. So I see we have a question back there. I'll get to you in the front.
Yeah, is there a term for when equal parts of the alcohol is derived from like honey and grapes? What you got? Does that have a term?
Is there a term for something where the sugars were exactly half from grapes?
Has anybody ever accomplished this before?
When you get to that in a moment. Is there a term for the exact split? I don't believe there is a term. Somebody's probably done it, maybe named it something, maybe combined mead and wine, call it wine or mead or something. That's
My way.
I
Mead meld.
would be. And it would not at all surprise me if somebody had done an exact three-way split between some kind of fruit, honey, and some kind of grain, so that you could equally call it a mead, wine, or a beer. And that brings up a question I'm betting a lot of you are now wondering, are there ones that are combination of honey and grain? Yes, that's called a braggot. One of the oldest styles of mead, actually. So we have about a minute and a half for another question.
I was going to say that or ask, if you use grape concentrate, there's a lot of other juicing concentrates in the
frozen ion. Like lemon, could you make a lemon mead?
Yes, you could. I don't think lemon would be quite
It was
as
good.
sweet, but
No, it was a good mead. He made one, but I don't know how he made it.
and I've no doubt it can be done in a way that would be good. Volume for volume, it wouldn't be as sweet. You could use the whole 12-ounce can. Maybe that would do. And apple is also very, very common. The way you do it with grapes is called a pilot. If you do that same thing with apple, it's called a sizer. And I've got a batch of exactly that just fermenting right now at home. The plain one that I'll back sweeten with grape juice concentrate, that's in the cold crashing state right now. And if there's anything else, any other kind of concentrate, yes, come to think of it, yes, cherry juice is also fairly common. I haven't seen pomegranate juice concentrate, but I've certainly seen just pomegranate juice itself used, all kinds of things. So we have another question back there, or you're just
No, I was just being different. That's what I said.
Right. We are now at 1 hour and 12 seconds. So that's it.
Free audio post-production by alphonic.com.